Hello students, welcome to EPG Pathshala. I am Dr. Nanaji Shevale, librarian, Gokhale Institute of Politics and Economics, Pune. In this module, we are going to discuss evaluation and measurement of information storage and retrieval system. This is part of the paper Information Storage and Retrieval Systems in Library and Information Science. In this module, we are going to discuss the need for evaluation of information retrieval systems. Second, different criteria for evaluation of information retrieval systems. Third, evaluation of outcomes like recall, precision, efficiency, and overall user evaluation. And fourth, information retrieval experiments like the Cranfield test, Medlars, the Smart Retrieval Experiment, the STAIRS project, and TREC, that is the Text Retrieval Conference. To begin with, we will see what is evaluation in general and then what is evaluation of information retrieval systems. In general, evaluation is a process of feedback against an investment in time, energy, money, knowledge, and intelligence. Information storage and retrieval systems are evaluated from several norms and viewpoints like users, economy, coverage, hardware, software, manpower, and environment conditions, etc., which can be discussed in detail as users. Say users, it must be done from the point of view of its users, their needs, knowledge, skills, and behavior. Second, economy, that is cost recovery and profit making aspects in relation to gathering information, organization, services, and usage, etc. Third is coverage, that is quality and quantity of information and its availability in different forms. Fourth is hardware and software. In this, the type of computers and software used for effective and efficient retrieval of information. Fifth is manpower, that is number of people and their skills used for the job. Last is environment, that is kind of users, their requirements, the institutional policy, programs, etc. One of the information scientists has applied Dr. S.R. Ranganathan's 5 laws of library science as norms for evaluation of information retrieval system. As we are aware of the 5 laws, the first law says books are for use. Second, every reader his her book. Third, every book its reader. Fourth, save the time of the user. And the fifth and last law is the library is a growing organism. Here, the first law implies maximum use of information contained in the database of information retrieval system. Here, the first law implies maximum use of information contained in the database of information retrieval system. It should be of definite relevance and constitute value for its clients. According to second law, readers' wants are paramount and they have to be satisfied. Thus, information storage and retrieval systems can be evaluated from the viewpoint of user satisfaction. As per third law, the system should be evaluated as per the quality of dissemination. That is, the ability to disseminate information contained in it in all forms or ability to project the information based on user requirements. As fourth law says, save the time of the user, means the system can be evaluated for its ability to keep the human efforts to search to a necessary and sufficient level using various tools, techniques, and skills. Now, the last one is the library is a growing organism. So is the case of information storage and retrieval systems. This can be evaluated by their adaptability, convertibility, and flexibility. That means the system should be able to respond to different or changed environments. Now, we will see what is the need for evaluation. We are going to see the views of two different information scientists. One of them is Keene and the other is Swanson. According to Keene, there are three major purposes of evaluating an information retrieval system, and these are: first, evaluation studies are conducted to compare the merits or demerits of two or more systems. Second, the need for measures with which to make comparisons between results obtained in different tests, and the third is the need for assessing the merits of real life system. Second, the need for measures with which to make comparisons between results obtained in different test situations, and the third is the need for assessing the merits of real time system. According to Swanson, evaluation studies have one or more purposes, like to assess a set of goals or a design prior to implementation. Second, to determine whether and how well goals are being fulfilled. Third, to determine specific reasons for successes and failures. Fourth, to uncover principles underlying a successful program. Fifth, to explore techniques for increasing program effectiveness. Sixth, to establish a foundation of further research on the reasons for the relative success of alternative techniques. And seven, to improve the means employed for achieving objectives or to redefine goals in view of research findings. Now, we will see the different evaluation criteria. An evaluation study can be conducted from two different point of views. The first is management oriented and the second is user oriented. When the evaluation is conducted from managerial point of view, the evaluation study is called as management oriented. And when the evaluation is conducted from user's point of view, it is called a user oriented evaluation study. Many information scientists advocate that an information retrieval system could always be Many information scientists advocate that an evaluation of information retrieval system should always be user oriented. That is, evaluators should pay more attention to those factors that can provide improved services to the users. To add further to this oriented evaluation, Cleverdon says that a user oriented evaluation should try to answer some of these questions. To add further to user oriented evaluation, Cleverdon says that a user oriented evaluation should try to answer some of these questions, like question 1: to what extent does the system meet both the expressed and latent needs of its users community? Question 2: what are the reasons for the failure or the system to meet the user's needs? Question 3: what is the cost effectiveness of the searches made by the users themselves as against those made by the intermediaries? Question 4: what basic changes are required to improve the output? Question 5: can the cost be reduced while maintaining the same level of performance? And the last question is, what would be the possible effect if some new services are introduced or an existing services are withdrawn? As with any other system, we expect the best possible performance at the least cost from an information retrieval system. We can thus identify two major factors here, that is performance and cost. We know that the system is intended to retrieve all those documents in a collection that are relevant. The system therefore should retrieve relevant and only relevant items. Here, one also needs to assess how economically does a system perform. Calculations of cost of an information retrieval system is not quite easy, as it involves quite a number of indirect methods of calculation of cost. According to Lancaster, some of the major factors to be taken into consideration for the cost calculation are: first, cost incurred per search; second, users' efforts involved in terms of learning how the system works; users' efforts involved in getting the documents through backup document delivery system; and users' efforts involved in retrieving information from retrieved documents. And the last is users' time, that is from submission of a query to the retrieval of references, and users' time from submission of query to the retrieval of documents and the actual information. A number of studies have been conducted so far to determine the cost of information retrieval system and subsystems. In 1966, Cleveland identified 6 criteria for the evaluation of an information retrieval system. These 6 criteria are: first, recall, that is the ability of the system to present all the relevant items; second, precision, that is the ability of the system to present only those items that are relevant; third, time lag, that is the average interval between the time the search request is made and the time an answer is provided; fourth, the effort, that is which can be intellectual as well as physical, required from the user in obtaining answer to the search request; fifth is form of presentation of the search output, which affects the user's ability to make use of the retrieved items; and the last, coverages of the collection, that is the extent to which the system includes relevant matter. Now we will see evaluation of outcome. The performance criteria discussed earlier can be measured easily. For example, the parameters related to the collation coverage and forms of presentations are related to policy matter and thus are defined by the system managers beforehand. However, the two other criteria, that is recall and precision, cannot be measured so easily. So let's see what is recall and precision. The term recall refers to a measure of whether or not a particular item is retrieved or the extent to which the retrieval of wanted items occurs. Whenever a user puts a query, it is the responsibility of the system to retrieve all those items that are relevant to the given query. However, in reality, it may not be possible to retrieve all the relevant items from a collection, especially when the collection is large. Thus, a system may be able to retrieve a proportion of the total relevant documents in response to a given query. The performance of a system is often measured by recall ratio, which denotes the percentage of relevant items retrieved in a given situation. The general formula for calculation of recall and precision may be stated as: recall is equal to number of relevant items retrieved divided by total number of relevant items in the collection, and the whole is multiplied by 100. Whereas precision is equal to number of relevant items retrieved divided by total number of items retrieved and multiplied by 100. Thus, recall relates to the ability of the system to retrieve relevant documents, and precision relates to its ability not to retrieve non-relevant documents. The ideal system attempts to achieve 100% recall and 100% precision. That is, it attempts to retrieve all the relevant documents and relevant documents only. However, this is not possible in practice because as the level of recall increases, precision tends to decrease. For example, let's suppose that in a given situation, a system retrieves A plus B number of documents, out of which A documents are relevant and B documents are non-relevant. Say, for example, C plus D documents are left in the collection after the search has been conducted. This number will be quite large because it represents the whole collection minus the retrieved documents. Out of the C plus D number, let us say C documents are relevant to the query but could not be retrieved, and D documents are not relevant and thus have been correctly rejected. Now, out of the remaining C plus D documents, the system misses C documents that should have been retrieved, but it correctly rejects D documents that are not relevant to the given query. Recall R is equal to A upon A plus C multiplied by 100. Precision is equal to A upon A plus B multiplied by 100. The relationship between the recall and precision is called as the inverse relationship. Now, we will see what is fallout and generality. While conducting a search, it is quite likely that non-relevant items have been retrieved in a given search. This is often termed as fallout. Generality: the proportion of relevant documents in the collection for a given query is called generality ratio. Now, we will see what is overall user evaluation. Practically speaking, this is the most important criteria for evaluation. Like, if a user gets his information and he expresses his satisfaction, that will provide overall qualitative assessment. Practically speaking, this is the most important criteria for evaluation. If a user gets his information and he expresses his satisfaction, that will provide overall qualitative assessment. However, the evaluation of information retrieval system is relatively new and the methods of measuring performances are yet to be developed. Vocabulary control and organization of information service has to be continuously using informative methods. The measurements of information seeking behavior of the individual and groups are to be analyzed and studied. So far in this module, we have seen need for evaluation, different evaluation criteria and evaluation of outcome like recall, precision, fallout, generality, and efficiency and overall user evaluation. Now, we will see various types of evaluation experiments like the Cranfield test, Medlars, the smart retrieval experiment, the STAIRS project, and TREC, that is the Text Retrieval Conference. Before going into the details of the evaluation experiments, let's see what F.W. Lancaster has to say about evaluation experiment. He has identified 5 major steps involved in the evaluation of an information retrieval system, and these are: step 1, designing the scope of evaluation; step 2, designing the evaluation program; step 3, execution of the evaluation; step 4, analysis and interpretation of results; and the last step, step 5, modifying the system in the light of evaluation results. So far, quite a number of evaluation studies have been conducted during recent years. According to Lancaster, first such study was conducted in 1953. Now we will discuss the first evaluation experiment, that is the Cranfield test. The first extensive evaluation of retrieval system was undertaken at Cranfield, UK, under the direction of C.W. Cleverden, and is known as Cranfield 1 project. The first Cranfield study began in 1957 and was reported by Cleverden in 1962. The project was designed to compare the effectiveness of 4 indexing systems, like: first, an alphabetical subject catalog based on subject heading list; second, a UDC classified catalog with alphabetical chain index to the class headings constructed; third, a catalog based on faceted classification and an alphabetical index to the class headings; fourth and last, a catalog compiled by the Uniterm Coordinate Index. Now we will see the system parameters of Cranfield test. Basically, this study involved 18,000 index terms and 1200 search topics. The documents, half of which were research reports and half of them were periodical articles. These were chosen equally from the general field of aerodynamics and the specialized field of high-speed aerodynamics. Now we will see the system parameters of Cranfield test. This study involved 18,000 index terms and 12,000 search topics. The documents, half of which were research reports and half periodical articles, were chosen equally from the general field of aeronautics and the specified field of high-speed aerodynamics. 3 indexers were chosen: one with subject knowledge, one with indexing experience, and one straight from library school having neither subject background nor indexing experiment. The results of the Cranfield 1 test contradicted the general belief regarding the nature of information retrieval system in many ways. Now we will see the Cranfield 2 test. The second Cranfield test was a controlled experiment that attempted to assess the effect of the components of index languages on the performance of retrieval systems. This study tried to assess the effect by varying each factor while keeping the others constant. Altogether, 29 index languages formed by the combination of concepts were tested on 1400 documents. Now, we will see the second information retrieval experiment in this module, that is Medlars. Medlars is medical literature analysis and retrieval system of the United States National Library of Medicine. Its performance was assessed during August 1966 to July 1967. The test was conducted on the operational database of Medlars, that is, a database of biomedical articles. The objective of the Medlars, the test was conducted on the operational database of Medlars, that is, a database of biomedical articles. The objective of the Medlars test was to evaluate the existing system and to find out the ways of improvisation. The document collection available on the Medlar service at the time of test consisted of about 7 lakh items. The selected user group provided 302 search requests. After carrying out the searches, rather than mere references, photocopies of the articles were supplied for the relevance assessment. The user was asked to mark each retrieved item using the scales like H1 of major value, H2 of minor value, W1 of no value and W2 value unknown. Using these values, the precision of the searches were calculated as precision ratio equal to H1 plus H2 divided by L and multiplied by 100, where L is the number of sample items retrieved. Now we will see the results of Medlars. When the figures for recall and precision for all the 302 searches were brought together, the average overall recall ratio was 57.7% and the precision ratio was 50.4%. Over the 302 searches, 797 recall failures and 3038 precision failures were noted. Now, we will see the third evaluation experiment of this module, and that is smart retrieval experiment. The smart system was designed in 1964 largely as an experimental tool for the evaluation of effectiveness of many different types of analysis and search procedures. According to Sultan, the 4 steps involved in this experiment are: step 1, take documents and search queries posed in English. Step 2, perform a fully automatic content analysis of text. Step 3, match analyzed search statements and contents of documents. Step 4, retrieve the stored items which are most similar to the queries. Some of the evaluation measures generated by the smart system were a recall precision graph reflecting the average precision value at 10 discrete recall points from a recall of 0.1 to recall of 1.0 in intervals of 0.1. Two global measures known as normalized recall and normalized precision, which together reflect the overall performance level of the system. Two simplified global measures known as rank recall and log precision respectively. Now, we will see the next information retrieval evaluation experiment, that is the STAIRS project. STAIRS is a storage and STAIRS is storage and information retrieval system. In 1985, Blair and Maron published a report on a large-scale experiment aimed at evaluating the retrieval effectiveness of a full-text search and retrieval system. This is known as STAIRS. The database examined in the STAIR study consisted of nearly 40,000 documents, representing roughly 350,000 pages of hard copy text used in the defense of a large corporate lawsuit. One important feature of STAIRS was that the lawyers who were to use the system stipulated that they must be able to retrieve 75% of all the documents relevant to a given request. Major objective of the STAIRS evaluation was to assess how well the system could retrieve all the documents and only those relevant to a given request, and measures of recall and procedure were used for this purpose. In STAIRS project, precision was calculated by dividing the total number of vital, satisfactory and marginally relevant documents by the total number of documents retrieved. For the calculations of recall, a sampling technique was adopted. Random samples were taken and these were evaluated by the lawyers. The total number of relevant documents that are existed in these subsets was estimated. One of the reasons for the failure of STAIRS was it was impossibly difficult for users to predict the exact words, their combinations and phrases used in all or most of the relevant documents and only in those documents. Now we will see the last information retrieval system evaluation experiment in this module, that is TREC, that is the text retrieval conference. In 1991, the US Defense Advancement Research Project Agencies, that is DARPA, funded the TREC experiments. In 1991, the US Defense Advanced Research Projects Agency, DARPA, funded the TREC experiments to be run by National Institute of Science and Technology, that is NIST, in order to enable information retrieval researchers to scale up from small collection of data to larger experiments. The objectives of the TREC experiments have been to encourage retrieval research based on large data collections. Second, to increase communication among industry, academy and government. Third, to speed the transfer of technology from research labs to commercial products. And the fourth, to increase the availability of appropriate evaluation techniques for use by industry and academia. TREC is an annual workshop aimed at building the infrastructure required for extracting relevant information from large volume of electronic documents. The first TREC conference was held in 1992 and research into improved text retrieval methodologies has continued ever since. The document collection of TREC is known as tipster collection. Tipster reflects the diversity of subject matter, word choice, literary style, formats and so on. Its primary collection is in gigabytes with over a million of documents. With this, we have completed the discussion on various aspects of information retrieval evaluation experiments and are now ready to conclude this module by saying that different users may want different levels of recall. Like a person going to prepare a state of the art report, say SOTAR, on a topic would like to have all the items, so he will go for a high recall. On the other hand, the user wanting to know something about a given topic will prefer to have a few items and thus will not require a high recall. Here, the major problem is that users very often are unable to specify exactly how many items they want to be retrieved. Recall assumes that all relevant items that have the same value, which is not always true. The retrieved items may have different degrees of relevance, and this may vary from user to user and even from time to time to the same user. Both recall and precision depend largely on the relevance judgment of the user. The judgment is quite subjective and there may be different degrees of the retrieved output. Finally, to conclude, one can say that the performance evaluation is crucial at many stages in information retrieval system development. At the end of development process, it is significant to show that the final retrieval system achieves an acceptable level of performance and that is represents a significant improvement over existing retrieval systems. To evaluate a retrieval system, there is a need to estimate the future performance of the system. Thank you, students.